Hello, everyone. Welcome to a live dev mentoring session. In those sessions, we help students of the iOS Lead Essentials program solve any technical challenge they're facing. Today, we're helping our student, Muhammad. Hello, Muhammad.
Hello, Caio.
Thank you for joining us.
Thank you for having me.
So, for how long have you been a software developer?
I have been working in software engineering for 4 years.
And 4 years in iOS specifically.
Yes,
Nice. So, the topic you chose was modularizing a legacy Objective-C / Swift code base. Can you explain a little bit the challenge? Is it like a large code base? Like, how big is it?
it is a marketplace application. It contains a lot of Objective-C code. Basically, the main dashboard of the application is home, store, notification, and profile. This is a monolithic application.
Right.
The code base keeps growing and it impacts our day-to-day work because it slows all of debugging session and it's hard to scale because of the issues like tag Objective-C and Swift, and we use WebView a lot. And we also have problem with MVVM implementation or MVVM. We use third-party UI and we want to split it. We want to start decouple it.
Okay. So you want to decouple from third party. Okay. So you have a monolith app. Everything is in one module with a lot of Objective-C and also some Swift. Everything you add from now on is going to be Swift, right?
Yes.
The new code. Okay. And do you want to also convert the existing Objective-C code to Swift at some point?
Yeah, we start to implement all new code in Swift, and we will add Objective-C interrupt if needed.
Okay. All right. So monolith, everything is one module, a mix of Objective-C code and new code in Swift, migrating some APIs. It's a marketplace app. It's a large code base with third-party dependencies. And what is the team size? How many people working in this code base?
Previously, we had 8 people, but currently we just have 4 people.
Okay. Spread as 8 people and now 4 people. And you want to modularize it.
Yes.
Mainly, what are the reasons you want to create modules? Few times.
Yeah, because the monolithic approach costs us a lot of build time and hard to debug. Whenever we try to debug something, we should build the whole application and it slows down a lot.
All right. So let's talk about modularization, because although modularization can help, if you do it wrong, it can actually make things worse. It can actually slow down things. So it can improve for sure the development speed. It can help with build times if done right. Otherwise, it will make things worse, slower. So let's start talking about modularization. There are multiple ways we can do modules in our applications. One way that works usually well is called vertical slicing, where you have each feature of your application in a different module. Let's say you have a marketplace, and then you have, let's say, a login feature where people can log in / register as well. The authentication module, you can have the shopping cart, and you can have the checkout as separate features that can be developed, tested in isolation as modules. So the idea of vertical slicing is to get your application and look at independent features that can be developed independently, completely independently. You don't want dependency here. You don't want the login view controller depending on another module. They are completely independent. They can be built and deployed independently, and also managed by different teams. You can have two people working in these two modules and two people working here. You can work independently, right? And why is feature slicing or vertical slicing popular? It's because when you create modules, you want it to be, you want low coupling and high cohesion. To get a feature and you split it into many modules, you have low coupling, but you have low cohesion because things that are related are too separate. And high cohesion is getting related things to be together. Right? So you can have a login, like register module, everything related to registration and login can be in one module. So everything is together. Everything that is related is together. So we have high cohesion. And also we have low coupling because it doesn't depend on other parts of your application. Right? So usually vertical slicing works very well in iOS applications, iOS code bases. Are you familiar with vertical slicing already?
No, this is new to me.
Okay. So this is in the main module in the program. When you reach there, you will see this in detail. But as an overall idea, that's it. When you create modules, you want low coupling and high cohesion. Things that are related stay together, and things that are different stay in other modules. Because one thing you want to avoid when you have modules is one module depending, having, let's say you have many modules. Let's say each box here is a different module, a different framework, for example, or a different package. But then the logging depends on this module, and this module depends on the logging. Yeah, this one depends on this one depends on this one. And the shopping cart depends here. Shopping cart depends on the logging, and the logging depends on the shopping cart. You have dependencies going both ways. This is gonna make your build slower. Because just creating modules is not gonna make the builds faster. You need to create decoupled modules. Why? The way the build system works. For Xcode to be able to build your application, it needs to understand the whole dependency graph. Okay, I want to build this framework, or I want to build this package. Does this package depend on other packages? If the answer is yes, okay, so I need to build those dependencies first, then I can build my module. So let's say you are working on the shopping cart, but the shopping cart depends on the login, checkout, and on this third module here. And you want to build the shopping cart. Xcode is going to look at the dependencies. Well, the shopping cart depends on the login, the checkout, and this one. Okay, so I need to build the login module. And then Xcode is going to say, okay, to build the login module, does this login module depend on any other module? Yes, it depends on the blue module. Okay, so I need to build this one first. And then it builds this one, then build this one, and then build the one that you want. Right? And anytime you make a change in this blue module, you need to rebuild everything. It's recursive. Right? That's why you want to eliminate as much as possible dependencies between modules so they're actually independent. And you can build them in isolation. Otherwise, you prevent also parallel building because Xcode tries to use as much core as possible to build things in parallel together at the same time. But if there's a dependency between these two modules, Xcode needs to wait this module to be built to then build this one because it needs to know all the symbols to build the other one. So if there's a lot of dependencies, you cannot use parallel build as well. So this will take longer. That's why ideally you want your features, modules to be independent. They don't depend on each other. Now you can build the shopping cart on its own and super fast. Actually, you can build both the login and the shopping cart and the checkout in parallel, concurrently, using different cores in your machine. That's much, much faster. And then eventually you need to compose all those features together to build an application. And you have an application module that will compose all of them. So when you're building the application, you need to build everything. But you shouldn't be building the application all the time. If you have a good modular design, you can develop everything independently and then compose in the application. But you can work on the shopping cart without running the application. You should be able to run your shopping cart feature without having to run the whole application. Because if you want to test your shopping cart feature and you need to run the application, you need to first log in. And then you need to select something in the shopping cart. And then you need to click on go to shopping cart or go to checkout. There's a bunch of manual steps. But if you decouple your feature, you can literally create a tiny application just to test the shopping cart and give you all the benefits of parallel building and having your modules being able to be independently deployable. You can reuse them in other applications if needed. You can build them in parallel. You can have multiple teams working separately. So that's the idea with vertical slicing. The other way that you see a lot is horizontal slicing, which is common. When you have modules like, I separate my apps in, you open, it's a monolith app, and you open, there's a folder called UI, one called network, one called database, something like this. And maybe one called models. Right? It's a common structure in small applications. It worked well. You just separate them into layers like, you have a UI, the network, the database, and models. But every UI for every feature is in the same module. Every UI for every network code for every feature is in the same module. Every database models is in the same feature, and so on. But with vertical slicing, you would have something like this. Each vertical slice, has its own UI, network, database, and models. UI, network, database, and models. Make sense? So the whole feature can be in a single module or in multiple modules. You can still have a combination of vertical and horizontal slicing. So you have a feature is composed of user interface, some kind of networking, some database, some models, some whatever the feature needs, some third-party dependencies. And each feature has its own separated UI, network, database. And you can say, Caio, but there will be a lot of duplication there. No, there won't. Everything that is going to be duplicated, you will separate into another module and you inject it into this feature. We show how to do this there in the lectures as well. Because if you want to have decoupled features, then the whole stack should be separated. Because you cannot have the UI here depending on a UI from another feature, then there will be a dependency. And then you start having the issues I described. So this works really well when you have like larger teams as well, and you have feature teams of people that are responsible for specific features in the application. Let's say I have 3 people working in the checkout, 3 people working in the shopping cart, 3 people working in login, registration, because they can work independently without getting in each other's way. And then they just compose everything in the application module and deploy the app. So you have these solutions. You can have vertical slicing, where the UI, networking, database, models for each feature is within a module. Or you can have a mix of vertical slicing with horizontal slicing, which means each feature, the UI for this feature can be in a separate module, the networking for this feature can be also in a separate module. That's a more advanced setup. I don't think your team of 4 people will need it. So you have 4 people working it, you probably don't need this level of separation. Just feature slicing sounds like something that could work well for you. Or you can go back to the default as well, horizontal slicing, where you just separate by domain here, like UI, network, database, and models. I like feature slicing I think for your case, it's the way to go.
One thing I would like to point out for Mohammed is because I'm not sure where you are in the program. I don't know if you've been exposed to these things, but like, does it make sense what the app module does here? The app module is responsible for composing all the rest of the modules, right? So it's the only one that is referencing the rest of the modules. You're going to see the arrows pointing from the app module to the rest of the modules, not the other way around. You're not going to see like the shopping cart or the checkout referencing the app module. So that in your code actually is going to be import app module. No, you're not going to have that. You're not going to import something.
For example, here we have an application target. This is an application. And here you have a third-party dependency, which is a module, right? So you have an application target, which is the application module. And you can have a bunch of separate independent modules, like feature modules, third-party dependencies. And the application module composes all of them. You will add all the dependencies here. That's why you have the arrows depending on the other modules. You add all the dependencies here. And here you compose everything. But the third party doesn't depend on anyone. The login register doesn't depend on any other framework, and so on. The checkout doesn't depend on any other framework. The application target will compose all the frameworks, libraries, pods, packages, whatever you're using here. That's the composition route that you talked about in the program.
Exactly. So any communication, you may be asking yourself, "Oh, but how are they going to talk each other? Like the login flow, let's say that you're going to show some listings or your shopping cart, that maybe, previously you had everything in one class or whatever, one module doing these things, right? So the composition route, the app module, will be responsible for the coordination of all these things. So you can develop them and maintain them separately, right? But the app module composition route will know about the communication and the coordination between these features.
We have some good questions here in the chat.
Yeah.
Which is common in modularity. What if there are some model files across login and shopping cart? Let's say we have some models here that are shared between these two modules. If you have something that is shared between two modules, you can even, if you think about high cohesion, you can even think, you know what? I'm not going to create two modules. I'm going to create one that have both, right? So you keep everything that is shared in the same module. There are other strategies. If you no, I need them to be separate modules, then you can decide to create a partial modules model and make these two depend on it. But now you have dependencies between modules. Right? This can depend here, and then you share them. But now every time you make a change here, you have to compile these two modules again. This can be problematic. This can slow down development because very soon all the modules will be here, and then every time you make a change here, you need to recompile all the modules. Another solution is to have duplication, just having different versions of the same module here. Because usually let's say a user model. Oh, you need user model in both. But the user model they use in login registration requires different properties, different methods than the one used here. Although they may have the same name, they usually are different. They have different properties because the shopping cart, it needs a user with a name, but also needs the user to have a credit card information, for example. But in logging, it needs a user with a name, but also with a password or something like that. So although they look like, oh, it's a user, they are different. So thus, instead of saying, no, I need to share this user, no, I'm going to create two users, one for each feature, because they require different properties. They represent different versions of the same user. Even though they may have the same ID, same user ID, same username, they will have different properties. And trying to put all the properties into one struct just to serve two modules will create coupling with not a lot of benefits. Oh, I'm not duplicating a property ID. Well, that's not a big problem, is it? It's just a property ID. because everything else is different.
So we're
I
naming.
recommend creating separate models per feature because each feature will require slightly different models. And you keep them separate. And about the database, we cannot have 3 different databases, can we? Yes, we can. We can have 3 different databases if we want to keep the data separate from each feature. It's possible. Or we just create a database interface with the methods each feature needs. And we have an infrastructure module with the actual implementation of these databases. That could be like a core database implementation that implements all the interfaces the modules need.
Yes.
So the features are still decoupled, and only this is an infrastructure detail for performance, for example. No, we want everything to be in the same database for whatever reason. Fantastic. The implementation can be shared, but the interfaces are separate. Does it make sense, Muhammad? I know it's really advanced what we're talking about
New
here.
things.
Yeah. Let us know. Yeah. Do you have any questions about it? Anything we can address now? Because you will see all of these in the program, but if there's anything we can already answer you, let us know.
Is there any best practice to implement that vertical slicing?
Yes, following dependency inversion, for example, following good design principles that we teach there in the program. If you want to implement vertical slicing to get the most benefit, you want the features to be decoupled from each other. Now, how to achieve that? There's a bunch of principles, a bunch of techniques to do it, like dependency inversion, composition root, all the dependency injection patterns like constructor injection, property injection, whatever you need to use to create this decoupling and inject whatever you want into the modules. For example, I want to have a shared database, but I don't want to couple my modules. Okay, so here I'm going to create interfaces with what I need. And the implementation will be in a separate module. That's the dependency inversion principle.
Mohammed, if you mentioned multi-repo, I'm not sure if I heard it correctly. I think that you shouldn't do it, at least initially. Just consider the fact that if you split your one repo into multiple repositories, you have a lot of maintenance you have to do. You have to use versioning. Whenever you update one of the repos, you need to like repoint your other modules that depend on it to the latest commit or branch or tag or whatever you're using in there. So it's a lot of maintenance that's required. So you can still modularize your app, but keeping every other modules in the same repository. It's exactly the case with the essential app project that we show in the program. It has multiple modules, but they all live inside the same repository. So that's one idea that I would consider, just to keep maintenance to a minimum, let's say.
Yes, so it's recommended start with a mono repo. So all those modules in the same repository, but they can be in separate projects, separate packages, like so they're decoupled, but just talking about version control, that is something else now. You keep everything together because then maintenance will be much lower. If everything is in a different package, you can still use packages locally, right, in the same repo, or you can separate into many repositories. If separating many repositories, you slow down. First of all, every time you update something, you need to fetch the new version of these dependencies in all the modules that depend on it. So it's a much slower process, a lot of maintenance of keeping versionings and bumping versions and making sure you're using the right version. If you keep everything locally in the same repository, it's much simpler. And for a team of 4 people, that's going to work really well. Like Git can deal with like very, very large repositories. For example, Facebook uses monorepo and they have like a huge code base, right? So it does work. It does scale well. We can separate into projects inside this repository. Everyone in the team will use the same repository. And there won't be conflicts if you separate into projects. Each team uses their own project. There won't be conflicts. So this is about modularization. If you keep your modules decoupled from each other, you have a much faster build times. Also, people will be able to change them in isolation without affecting others. That's the best approach. That's the recommended way of doing it. Minimize dependencies using the principles we teach in all the mentoring sessions we have here, in the lectures as well.
I guess one part which is very complicated to do is when you have a legacy code base, like we think it's the case here, and you want to move to this design, but what's in between? That's very problematic. So how do you get there? I, at least for me, I think a step-by-step approach is best. So you just try to extract one module, keep it nice and clean, try to move only the classes or the entities that are valid to be moved there, and just see how it goes, learn from it. I wouldn't recommend starting to split everything into, I don't know, 5, 7, 8 modules at the same time. It's just a nightmare to maintain and to uh, like keep being productive. Like, 'cause I guess your team managers will still want you to deliver some features or bug fixes in the meantime. So you would avoid getting into a state where you say, but I cannot release now. I need 3 more weeks to finish my whatever modularization project you started. So just do tiny pieces at a time. If you can add tasks, that's ideal. Just do it slowly and see how it goes. You can ask more questions in the community if you feel it's not going as you expected. It's hard. Like this diagram Caio showed, yeah, it's very nice and ideal to spot to be in, but it doesn't happen overnight. So
I'm going to
you
tell you
just
what's
need to
going to
work at
happen
it.
if you try to do everything in one go. You get into a point where your code base doesn't even build anymore. You'll be like for hours trying to build and dealing with build errors, and you might get stuck. So I highly recommend what Bogdan just said, to slow things, always building the project, always be in a green state, always the test passing, always the project building. Do one, extract one class. Can I make it build? Does it work? Okay, now another one. Does it build? Does it pass the test? Okay, do another one. Do it like a slow migration. Otherwise, if you try to do many things at the same time, you can get into a stage that you're going to have to revert everything because the project's not even going to build.
Yeah, and commit often, use it as a checkpoint.
Yeah,
That
it's
okay, you're
building, the
in
tests are
green.
passing,
That's it.
commit.
You can try something. If it doesn't work, revert to the
Yeah.
previous green state, right? So, and when I say often, like maybe it's whatever, it's like a couple lines of code changed. Just commit. It works. That's no problem.
Yes, and I recommend like code that is working with Objective-C. I don't see a point in migrating to Swift. It's working, it's stable, you don't need to change it. Keep it in Objective-C. It's fine. It does like interrupts with Swift pretty nicely. Like only if you need to change the code to do something else or rewrite it, then you do it in Swift. But something that is working and it's fine, don't touch it. Like it's working.
Yeah, that's very important in legacy code bases. It's very important what the code does, not what it should do. So whenever you have this bright idea to rewrite or refactor, you usually change the behavior. If you don't have tests that show you what the behavior is, you change it and you basically just add problems to your app, to your business. So it's like Caio said, don't put the tag like, yeah, that's legacy code, I need to change it. Like if you rewrite Objective-C code into Swift with the same principle, it's still legacy code. So you just thrown away many hours of development and you gain nothing, almost nothing. So just like if the code works, just leave it as it is. um, it's a lot better than having maybe a better design but the code not working. So the things we recommend in the program, they are all interconnected. So tests to back you up so you can refactor and improve your code base one step at a time, modularize things, but they're all interconnected. So that's why we probably recommend this slow step approach, just doing one thing at a time and building from there.
A little bit at a time. In a couple of months, maybe 1 year, you achieve your goal. Don't try to do everything in one go. Otherwise, you're going to have to tell your boss, hey, we need to stop for 3 months to get this done. And then at the end, they will have the code base doing exactly the same, but now it's in Swift. But like for the clients, there's no benefit. The code base does exactly the same thing still. And you just wasted 3 months and you didn't add anything new to the code base, right? So that's why it's a gradual process. As you add in new features, you start writing Swift, writing tests, improving the design little by little. Always moving forward, always delivering new features, always like getting items in the backlog and getting it done, always moving. So your boss is happy, your customers are happy, and you keep delivering value. You shouldn't stop delivering value to improve the code base. You should try to find a solution that does both at the same time. The improvements will be a little bit slower, but you're still delivering value. So people are happy. So people are getting benefits from your work. That's why it's important to do things little by little. Make it better, a little bit better every day. Going towards this goal of modularization. So sit with your team and come up with a plan. If you want feature modules, for example, okay, let's do feature modules, vertical slicing. And let's choose one feature. What is the next feature we need to build? Or what is the next feature we need to make a change? Okay, that's the one. And let's make this feature now a module. It's going to take some time. You're going to have to plan around it. You're going to have to choose a good design for it. But it's going to be the first experiment. Once this is done, you look at other features. One thing at a time with a plan. Learn, because maybe you're going to have a bunch of problems during this modularization. That's going to bring knowledge to the team. When you do the next feature now, you're going to be better. You're going to be faster. You're going to have a better path, a better structure to do it. And the most important thing is that everyone needs to be on board with those changes.
Exactly.
Otherwise, let's say 2 people are trying to modularize and the other 2 are trying to keep it as a monolith. Then you're going to have conflict in the team, because you start extracting classes, people come and bring it back to the to the monolith, and then it's just going to be fights internally and there will be no progress.
Exactly. This is key. Like sitting down and coming up with a plan and everyone being aligned, to in terms like what needs to be done and what needs not to be done. Actually, this might be even more important, things that they shouldn't do. There's no other way around that, like this is key. Otherwise, it's like 1 step forward, like 5 steps backward, like you're never gonna end up with something good.
Yes. Another thing you mentioned here is third-party dependencies. Third-party dependencies can slow down your application as well. Especially if you add a third-party dependency with CocoaPods, for example. You add a library and it brings like 100,000 lines of code to your code base. This is code in your code base that actually needs to be compiled as well, right? So you need to treat dependency just like I'm talking about the modules here. If you have I don't know, here, an Alamo Fire dependency, and the checkout uses Alamo Fire, for example. To be able to build the checkout module now, first you need to build the Alamo Fire module. And if this is a huge module, it can take like 3 minutes just waiting for Alamo Fire to build, to then build checkout, right? Or you have Crashlytics, which is also a big library. Or you have like Firebase and so on. You start adding up to the time it takes to build. So there's a couple of strategies you can have here. One is also dependency inversion. You will define interfaces you want for your networking, and you will make the Alamo Fire implemented. With extensions or something that you do outside, maybe in the app module or in the infra module. Now you can build the checkout without Alamo Fire, which means you don't need to build Alamo Fire or Firebase or Crashlytics or whatever other dependency you have, right? Dependency inversion as well. Instead of your modules depending directly on Alamo Fire, you invert the dependency. You define the interfaces you want, and now someone else needs to implement it. This also helps you later say, you know what, we don't want to use Alamo Fire anymore. Let's use URL session. You just change the implementation without changing the checkout module. Right? Also gain flexibility. You can also test the checkout more easily because you're not dealing with a concrete dependency as well. We can just inject like stubs and spies instead, test doubles. So there's a lot of benefits of decoupling your modules from third-party dependencies as well. One is build time. You don't need to build the dependency all the time. You also make testing easier. And another solution you can have, because no, I need to use Alamo Fire directly. At least use a binary dependency that's already pre-compiled, so you don't need to compile it all the time as well. You can pre-compile it and use the pre-compiled binary. Because this can add up. Like, okay, it only takes 10 seconds, but then suddenly you have now 50 dependencies on your CocoaPods file. Now this can take half an hour easily.
Yeah. And usually the more source code you have in your project, the higher the chance the Xcode indexing will go haywire and suddenly autocomplete doesn't work. You don't see your types properly colored or underlined or anything. So it's clear that Xcode was not designed like this. So whenever you can, just it's like Caio said, even for small library, small dependency, if you use a precompiled binary, you use help. Your build times, Xcode deal with less source code. So every one of these adds up. So and at some point you will definitely see visually like everything going a lot faster. But it takes a while until you get there.
Yes. We have a good question here. Will app module handle navigation between screens? Yes. That's the key, because let's say after you finish logging, you want to present the home screen, but the home screen is in a different module. If you want to do this directly from the login to home screen, you are coupling the login with the home feature module, right? If you want to decouple them, you will have separate modules, like you have a home module, a login module, and the app module will handle the transition from one to the other. How? Usually the UI, we have some callback here, like, I don't know, on button tapped.
Yeah.
The app module will listen to this on button tapped and present the home screen, for example. So this way, the modules are decoupled and the app just handles the transition. You can create a class here. You can call it a flow, a coordinator, or something like that. But if you want to decouple the modules, they shouldn't know about concrete types. And usually you do the navigation in the app module, because navigation usually is app specific. You don't reuse across applications. You can have different applications with different flows. On this application, we use a navigation controller. In another application, we use a modal or something else. Or maybe in a macOS application, we don't use navigation controller. We use a split view controller, right? So navigation is application specific, thus usually stays in the app module. So about dependencies, we need to invert those dependencies to avoid them influencing build time and also avoiding influencing the design of our application as well. Coupling too much with it and then being hard to replace later, which happens a lot.
Yeah, just be careful about all the import statements that you have. And whenever you see importing a third party or something like that, just reason about it. Look at For instance, you can comment the import and see the compiler showing you exactly which symbols you need there, and you can think about what abstractions you can create to decouple that. So that could be a step when you're trying to modularize, because it's very clear that when you start, especially on a legacy project that was not built with modularization in mind, it's not going to be easy. So there's no there's no way around it. And it's like Mike said, you have to maybe try out a few things, and decide, like, I want to maybe modularize, extract a module first which has a concrete dependency on a few third parties, or I want to clean up the dependencies first and then modularize. Like, you need to come up with your own steps and your own order of things. Otherwise, if you try to do everything at the same time, it's not going to work out very well, especially if you haven't done it before. It's a can be a tough exercise to do, right? So,
And usually when refactoring code, it gets worse until it gets better.
yeah.
It's a step. It's like, okay, I have a vision where I want my code to be, but to get there, I need to do a bunch of steps that maybe it's going to get ugly until it gets better, right? So it's a you need to have a vision where you want it to be, and a vision like this, where you want it to be, and work towards it. And maybe it's going to take 3 months, 1 year, but that's fine. If you're going towards that vision little by little, eventually you get there. If you have a plan and a vision where you want to be, then you can realize the vision. But if you're just going day by day, just, oh, I think this is going to help, I don't know where I'm going, it probably won't get there, right? So sit with your team, show this video to them so they can watch it as well. And you guys go to the drawing board, draw some ideas. You understand your code base better than we do, and start planning. Okay, let's start with this feature. Let's run it as an experiment. Let's learn from our success and failures in this experiment, and let's keep improving and improving and improving. Always towards the goal, which is to have these decouple modules that can be reused and built independently, tested independently, and also always checking the build times, because you may think you're improving things, but it may slow down, and then you need to go back and find what is slowed down, what is the problem here, what is the dependency creating the slowdown. Okay, let's invert the dependency so we don't need to keep building this third party all the time, right? So there'll be a lot of investigation, a lot of debugging techniques. You will learn this in the iOS Essentials and also in the tooling course that we added there in the academy. And keep learning and practicing, keep learning and investigating issues in your code base and improving it.
Ever seen the tooling course, Mohammed? Are you aware of its existence?
If you go to academy.essentialdeveloper.com, you log in as a student. There is an extra course that Bogdan recorded with a lot of those ideas implemented with Xcode.
Oh, yeah. I haven't yet see that.
Yes.
Make sure you check it out. It's fantastic.
Okay. Thank you for mentioning.
Absolutely.
Yeah, there's at least a few lectures on Xcode build times. So just watching these should give you a more ideas and principles about what to check and how to, like, start from measuring your build time and see where it's actually being worse, which of the build steps are problematic in your case, and then you can see some strategies there on how to fix those. Modularization is one of them, but it's not always the solution. So depending on your situation, like, I also saw a comment about this, but if you mentioned having a lot of Swift and Objective-C in your code base, if you expose a lot of Objective-C to Swift and the other way around, then the projects will build a lot slower. So a basic recommendation which I can give you right now is try to reduce this interface. And what's the interface? Well, so Swift being exposed to Objective-C is all the classes that inherit from NS object or all the APIs that are marked with @Obj-C. Try to limit these. So only expose what you need. That's it. And the fewer you have, the faster the build would go. In the other direction, from
We just write this down.
yeah.
So we need to limit, if you want to improve build times, the Swift to Objective-C interface. How? Everything that inherits from an NS object will be exposed to Objective-C. If you have a Swift class that inherits from an NS object, it by default is accessible through Objective-C, which means there is more code to compile in the headers. So avoid inherit from an NS object when you don't need it. If you need it, no problem. But if you don't need to inherit from an NS object, avoid it. And if you need to inherit from an NS object, one thing you can do is to still make your type maybe private or file private if possible, because then it's not exposed to Objective-C. You still have the inheritance from an NS object, but it's not exposed in the headers. So less things to compile as well. Or make it private if possible. Also, avoid using @Obj-C. So you have a method and you make it available to Objective-C. It's more things to compile as well in the header. So avoid using it if not needed. If you need it, no problem. You can use it. Or make it private as well if possible, to not expose it there. So this is exposing Swift code to Objective-C. By doing this, you already can improve a lot build times.
I have experienced when too much Objective-C ends with interrupt because compiler gives misleading error. So just fight the compiler, not fixing the code. So
right. Because if you want to expose Objective-C code to Swift, you need to import those types in your bridging header. If you have an application module, you need to create a bridging header, and everything you import here from Objective-C will be exposed to Swift. Thus, you can use those classes, types, enums in Swift, even though it's written in Objective-C. If it's not here, you cannot see it. And the other way around, if you want to expose Swift to Objective-C, as we said, you either inherit from this object or you marked your types with Objective-C. That will expose them to Objective-C. But limit this because then you can improve build times as well. Only expose things that needs to be exposed during this migration, and over time, you start limiting them as much as possible. Always try to make things private, see if it still compiles. If it doesn't compile, the compiler is going to show exactly which types depend on it, and then you can have a plan to eliminate a dependency in the future.
Yeah, and just start by, I don't know, getting a count of how many types are exposed. So you can do a search after, let's say, classes inheriting from NS objects, see how many you have, and you can also look at the bridging header, see how many headers are there, and that should give you a clue. And from my experience, especially a large bridging header, and it doesn't have to have many files, but those files can import other files, and those files can import other files, and you can have maybe 10,000 lines of code in a bridging header, and this bridging header gets imported automatically into every Objective-C header you have. So you can imagine the amount of code that the compiler has to deal with when compiling. And this happens for every build. So it's very complex. Like there's a separate lecture, especially on that, because the way Xcode deals with these two languages is pretty complicated. But try to at least see how many interoperability points you have, and try to clean them up, as Caio said. Like especially the bridging header. In my experience, if you manage to remove imports here, that's very useful. So just an example, let's look at this case. So we have the base view controller and the view controller headers, both imported. Now, if I recall correctly, if you go into the view controller header, I think it also imports, it also imports the base view controller. So that's already a duplication of imports, even though Xcode can be smart and avoid duplicating that. But you see, like, if the bridging header already imports the base view controller and another header that imports the base view controller header is imported twice for every file in your project. So that's a very easy way you can remove the size of the bridging header, is by just removing the direct import to the base view controller from the bridging header, and everything should still compile. So that's just one example of where you go in, and if you pay close attention, you can immediately see some improvements you can make, right? And those really are visible in your build time performance that you get. So if you do a proper cleanup, you could speed up with, I don't know, tens of minutes, because Xcode is really not, especially when dealing with those two languages, with Objective-C and Swift, it cannot use the full power of the CPUs to parallelize. It has to wait, because I shouldn't get into the details, but at every step of the compilation, it needs to finish it so it can start the next step, which requires the results from the previous step. Whereas when you have let's say, just a Swift project with only Swift files, it can build them in parallel, because they do not depend on anything, let's say, like a common step before. So it can, I don't know, compile one file on each core that your machine has, and that's super fast. Whereas with these Objective-C and Swift, things can really slow down if you use everything from everywhere, which is the case for at least some projects that are legacy, and people started to add Swift without knowing this. So just pay attention about it, and just, I would say, measure, because if you build with I think it's timing.
You show in your lecture
Summary,
exactly
It's
like how to figure out like which are the slow files to build, and then you can look at each step of the build, how much time it take. Like Xcode gives you all the data, and you see which was the slowest step, and then you look why was it slow, and then improve it and improve it, and you can improve your build times by 75-80% just by doing that. Because you need to remember that imports are recursive. So if you import this view controller, the compiler is going to look, oh, there's 2 more imports here, so I need to also import this. We need to also import this. So it keeps importing, and your kit imports foundation, and then foundation imports all these, and all this is added to your headers. Another thing you can do to improve is in the headers, when possible, you should use forward declarations. You don't need to import UI kit in the headers here. If you only need a UI button or an NS string, for example, you can just use a forward declaration. How is it? Class? UI button. You're just saying there is a class called UI button, but you don't need to actually import the whole UI kit framework into your headers. Right? I need this just say there is a class called UI button. Trust me, it exists. And in the implementation side, you import the framework. Thus, the headers are smaller now because you don't need to have UI kits. So there are a bunch of techniques you can use to reduce your headers. And this will really improve your builds, especially in large code bases. Actually, you said it doesn't even need to be that large, right, Bogdan?
Yeah.
Even like medium or even some small code bases can see a negative impact of large headers. Because when you have like a legacy code base that was built in Objective-C, it's all Objective-C, and now you want to start adding some Swift, you need to expose everything to it. And you have this huge bridging header. Okay, the project compiles now, but it takes forever because it cannot parallelize anything anymore.
Yeah.
So we need to be careful with that and have a strategy. Otherwise, it can really, really slow down.
Now I understand why some people says that the bridging header is the main bottleneck of the build time.
Yeah.
Okay, thank you.
It is a main one. Because what happens is all your Swift files, every Swift file you have depends on this bridging header. So whenever you change any of the headers that are imported there, all your Swift files will need to be recompiled. Just by that. If you add just one line in one header, everything is recompiled. So because Xcode was built with incremental builds as an idea, where Xcode would only rebuild what changed, so you can get these slow builds. But in this case, if you have this huge bridging header, it usually works against that, and you end up almost clean building every time. So it's very, very slow, and people don't know that. Like, I mean, when Objective-C was the default language, a lot of teams would just have their headers contain everything that the implementation file had. There was no difference. Like, you wouldn't have private methods or private extensions, or like everything that was in there was public. So the headers was huge, and whenever you needed something, like, okay, import this, import that, it's very easy to get this into a horrible state for the compiler. So the compiler has all these cyclic references, and it's like it has to spend a lot of time to understand how to actually build it. So it's very, very easy to see a large build time because of that, and then you can say, okay, I need to modularize because my build time is slow, and you split it into modules, and you have the same or worse build times because you are still having the same problem. So that's why it's important to measure. At least I've done this countless times, just anticipating what the optimization should be and doing it, and I never got the result I wanted. So it's always measure, measure, measure. Like, I cannot stress this enough. At least in my experience, it was always like this. Whenever you think something is the problem, it's not that thing. Like, it's something else. So
And if you don't measure,
yeah,
you may feel like it's improved, but actually it's worse now. So if you don't have a measure before optimizing, you don't know if you actually optimize or not. It's just feeling, and you're usually wrong. So you need to have some measure before and after to make sure that the optimization worked and actually you had a good benefit from the optimization. And thinking about a monolith here, right? We have a monolith. So every Swift file is in the same module, right? And let's say you are always changing Objective-C and Swift file all the time, which means any change you make to an Objective-C file, you need to recompile all your Swift files if it's in the bridging header. Every time you change the view controller here, since it's in the bridging header, you need to recompile all your Swift files because this is added to the headers of the file. So this can really slow down when you have a monolith where everything is in one module. You feel this, it's less painful if you have multiple modules with less files because it's less files to compile, less dependencies. But if everything is in one module, you're going to get the biggest penalty of
and the other way
the build
around.
times.
Because
Yes.
if you have a Swift class that's inherited from NS object and you change it, then Xcode needs to regenerate the Swift header, which is imported by a lot of your Objective-C files probably. So
Yes.
then you recompile the other part of the project just with a small change. So it's like you see, this can easily go wrong. It and the compiler cannot help you. Like when you reference symbols and do imports, and it's like there's no way to optimize it on the compiler side. Like you have to go in and clean up those dependencies one by one. There's no way around it. Like the compiler can do some things, but this is something it cannot really solve.
Yes.
So
That's it. Minimize the Swift to Objective-C interface and the other way around as well. When you are in this 50-50, at some point your code base will be 50% Swift, 50% Objective-C. Any change you make will recompile the other side, you know. So avoid it as much as possible. Always measure.
What if I separate all Objective-C code into a separate module and just import it to add module? Is there any cons to that approach?
So keep all Objective-C in one module. Well, you still need to build the module, right? Every time you change this module, you will have to recompile the modules that depend on it.
Yeah.
yeah, I guess that's the main question is on Caio's idea, where you have to look at what you're changing when you're making changes to your code base, because usually you kind of change the same files more or less. So if you change a lot the Objective-C, then it really doesn't make that much sense. If the Objective-C is something stable that you're not changing a lot, or maybe just a few classes of Objective-C are subject to change, and I don't know, you have 100 classes that never changed, then it might be a good idea to separate those into a separate framework. But again, it depends, because you see when you try to move like one file or two files, you see that they depend on 5 other files, and these files depend on other files. And it's like, it's very hard in a legacy code base to extract something and put it in a module, because it has so many dependencies. As you go through the exercise, it would get easier, but at the beginning, it's very, very hard, and it might be discouraging. You have to be, like I said, you need to have that plan. You need to be committed with all the team to be doing this.
Yeah.
Otherwise, it can be very, I don't know. You have moments of doubt. At least I did.
Yes, you will see that at some points maybe your build will get slower in this transition phase. But you know that at the end of the tunnel, when you see the light, it's like it's gonna be faster. You need to have faith there in the process, because there will be times where you will feel like you're going to the wrong direction, but try to optimize, try to measure and improve. But if you have a vision that like, okay, when I get to this stage, things will be better, things will be good, and you keep going towards this stage, even if in the meantime it might get a little bit worse, if you know that you're going towards this solution, you will get better eventually. We eliminate dependencies and have these decouple modules that can be tested, implemented, and even run in isolation. That will speed up a lot the process. Okay, so from your questions, coupling with Objective-C can be a problem for build times if not done correctly. So reduce the headers that is exposed to both Swift and Objective-C. But apart from that, you can see there in the lectures as well, like how to create your interfaces in a way, add like Swift annotations to Objective-C to make it more friendly to Swift. For example, you can set lightweight generics to your NS arrays and NS dictionaries. So when Swift accesses your arrays, it has type information. It's not an array of any or a dictionary of any to any hashable, right? So at least you have some type information that you can carry from Objective-C to Swift that will improve the APIs. Tight third-party integration, dependency inversion. If you want to decouple a module from a third-party dependency, define the interfaces that your module needs and implement them in another module. Modularization needs to be done. You need to be very careful not to make the problem worse. If you're creating modules, ideally they should be decoupled from each other. web view everywhere. You need to refactor to native. I don't think that's a problem. I think that's a task. We can have a mentoring session specifically. If you have a specific problem about this, we can talk about it. But this is just a feature you need to implement. I don't know. There's no problem with that. An MVVM approach that access array element directly from packing store. Can I have a quick look at this? Because MVVM is just a UI pattern. It works. It scales pretty well. I don't think you will have an issue with MVVM. It's well implemented. So you have a problem here. So you have a view model with a data source, and to access the values, you need to get it's an array of arrays. You need to get the item as a specific section for a specific row. And this can be new.
Yeah, because at some point the view model update from the background. So when we scroll or when we select a cell, it crash if we don't use that.
Okay, but this is now a problem with the data synchronization. If the view model data changes, you should immediately tell the table view that the data changed. You should never get to this stage. This should not be necessary. If you need to use safe unwrapping of an array element, is because there is a problem with the implementation. Because if you tell the table view, there are 10 items to present, the table view is going to say, fantastic, give me item 0, 1, 2, 3 until 10, right? This is never going to break because you're telling table view there's only 10. Table view will never ask for element 11, correct? Now, if you tell, hey, table view, there are 10 items here, and then you change the underlying data source that is feeding the table view, you need to tell the table view that the data changed. Otherwise, this will prevent it from crashing. Let's say there were 10 items in the table view, and then you told, hey, table view, there are 10 items here, and then you updated the data source to have only 5. If the table view try to get the element 6, 7, 8, 9, it will crash, right? But this should never happen, because as soon as the data changes, you need to update, tell the table view to reload the data. There's new data available. And there are patterns to do it, right? For example, you can use an observable pattern, you can use some kind of closure. Every time the data source changes, immediately you update the table view. They need to be always in sync. Because you can say, well, I added this safe access to the index of an array, and now I get an optional back. But the problem now is that, sure, it's not going to crash, but you still have a logical error in your application, because maybe you are showing the data changed. It's not going to crash, but maybe you're showing the wrong data now on the UI because you didn't update your table view. So every time the data source changes, you need to tell the table view to reload the data. That's mandatory. Otherwise, it's a violation of the API, and there is no safe access to an array that will solve that problem. The problem here is the asynchronous mutation. But since it's a UI class here, we're talking about UI, everything runs in the main queue. The main queue is serial. You shouldn't have a problem because everything is run serially in the main queue. There's no multi-threading, accessing, and mutating the table view. Everything is serial. There's been a change in the data source. Serially, you tell the table view that there's been a change in the data source. And then you're never out of sync. So you shouldn't have to use a safe accessing an index safely. It means it's a violation of the API. And although it wouldn't crash, you will still probably have logical errors showing the wrong data at the wrong time. So the solution here is not to use new checks or safe accessing. It's to actually make sure that every time there's a mutation to the data source, you will notify the table view immediately in the same run loop, so the table view can accordingly update the data source. And there are many patterns for that. We showed that in the program with MVVM. You can use a closure, you can use an observable, you can use RX Swift combine. There are many ways of doing the same.
I think I should revisit the lectures. Okay,
Yeah,
thank
For
you.
sure.
For example, I can see, like here, did select row at index path. It's very common to see code bases that do this. Like, okay, you selected a cell, you tapped on a cell, and then you say if let item equals, or if let item, then you use navigation controller and you present something. Navigation controller dot push, and you present a view controller here, right? Otherwise, it does nothing. Just print like item. The problem is now, okay, I'm using this, I'm accessing the data safely, and I have a problem. My data source is out of sync with my UI. So the user is tapping on a cell, but nothing happens because there's no item in that index path, right? So that's a problem. That's a problem. That's a logical error, and there's no crash in the app. There's no logging. There's nothing. So you have a bug in the application where the user is tapping on a cell, but nothing happens. He needs to close the app, open it again, and try again to get to the screen they want. That's the problem with using news and safeguarding everything when you have a logical error. It doesn't crash, but doesn't work as well. Make sense?
Yeah.
So the solution is to actually fix the problem, which is to always keep the UI in sync with the data source. Make sense?
Yeah. It makes sense to me.
Awesome. So we talked about a lot of things today. It's a lot to digest. I recommend you watch this session. I'm going to send you the link of the recording. Watch it again. Watch with your team. Talk to them. Come up with a plan and try to implement little by little. Adapt as needed. You're going to learn a lot. There will be successes. There will be mistakes. And you will learn a lot from this process. You can ask for help in the community as well. We can also have another mentoring session. You can bring other issues as you start implementing this. We can help you. And I think that's it.
Awesome.
Make sense?
Yeah. So I got a lot of things here, especially the modularization, vertical scaling. It's new to me. I will look for it.
Yeah, I recommend you finish the lectures first because then you'll be more prepared to start this refactoring. Okay?
Yeah. Sure. Okay.
And then check Bogdan's course as well,
Yeah.
the tooling course. You can jump to the specific Swift to Objective-C interop lectures,
Yeah.
right? That will help you. But then when you have time, you complete the whole course. Okay?
Okay. Okay.
Cool. Awesome. Thank you so much for joining us, Mohammed.
Thank you, Caio, Mike, and Bogdan. Goodbye.
Thank
Yeah.
you.
Bye.
Bye.
Take care.
Bye. All right. Hello, everyone in the chat.
Hi, everyone.
How to share common UI components like buttons, text fields, icons. Does it make sense to have a specific shared UI module? Yes, you can have a shared UI module, but now the way you use the shared UI module, there are different strategies. You can have a shared UI module. Let's say shared UI with common elements like buttons, things that is not specific to any feature. Like you just want every feature to have the same button, for example, like an orange button with rounded corners. It can be in the shared UI module. And you can either inject those views into the modules to keep them decoupled, or you can couple your modules to the shared UI. If it's a stable shared UI, that shouldn't be a problem because it's stable. It doesn't change a lot. But if this is a UI is changing all the time you're making changes to the rounded corners and changing everything, it may be a problem because now you need to recompile all the modules every time there's a change here. And if this is changing a lot, it's a lot of building time. But it's something we're going to have to measure and see. If it's a problem, then maybe limit shared UI. Sometimes having a little bit of duplication can be the solution. I've seen many cases where actually having different buttons for each model is the best. Especially because every now and then it's like, okay, I want to change slightly the rounded corners, but only for the shopping cart. And it's like, oh, but it's a shared UI. I don't want to change it in the checkout. I wanted the checkout to still be the same. It needs to be green. Now it's a problem because you're going to have to add a Boolean. Like button is green, and set up, and then you're gonna start seeing that your UI that looked like it was shared, it's not that shared because every module wants a slightly difference in it, and then maybe it's time to separate it. But if everything's exactly the same, you can use a shared UI module. If you're having build times issue, maybe think about dependency injection, injecting those UIs into your modules. There are different strategies. It depends on the problem you have. But yes, you can have a UI shared module. Just be careful.
Or you can apply the same technique we recommended for third parties and just invert the dependency. If you can still share it, but only reference it from the composition root and just use an abstraction. If it's just sometimes it's just a UI view, your UI view controller, and then it's very easy because your other module can depend on the base class, like the UI view, and add as a subview and be done with it. Or if you need more behavior, you can still use abstractions like protocols or closures.
What is it saying? You can always solve a computer engineering problem with one extra level of abstraction, right?
Yeah.
But there's a cost for this extra level of abstraction in performance, in complexity. So it depends on the case, right?
Yeah.
Like a question here, are there any downsides of modularization? Yes, the maintenance. If everything is one module in the monolith, everything is accessible, everything is easy, right? But with modules, now we need to maintain modules, you need to deal with builds, settings, making sure everything is connected correctly. And if there are different repositories, now you need to deal with package managers. It's always a trade-off. So use it when actually needed. Yep.
I saw a comment which triggered an idea which I wanted to mention is you have this modularization, let's say, and it's very easy to breach because somebody comes in, a developer in the, let's say, in the login module and needs something from the checkout and just writes a import checkout and uses a type from there. And now your modularization is not completely broke, but it's worse. And unless you're very, very careful with this during, I don't know, code reviews or when you merge it, it's very easy to breach. Like, so the Xcode would not, I don't know, make a big thing out of it. It would just implicitly find that dependency and build it. So it's very easy to get from this state of clean separated modules to every module depending on every module, like you showed in the beginning of the session, just with 5 lines of code, 5 imports or something like that. You
Yes.
can break it into pieces.
It's very easy to break it,
Yeah.
right?
Yeah.
So it requires discipline. If we're
Yeah.
doing modularity, it requires discipline. And especially you need to understand how the build system works, because within a module, for example, let's say you have a class called database. If you make a change to this database class and it doesn't depend on any other class within this module, the compiler can be smart enough and only recompile that file that changed.
Yeah.
But cross-module dependencies is different.
Yeah.
Let's say the UI here depends on a model of another module here. Now, this UI depends only on a model class. Let's say a user model. But the way you import the whole module, we don't import a file in Swift. Which means if you make a change in this is a modular dependency. To compile now this module, you need to actually import the shopping cart because there is a dependency here of one class to the other. You need to import the whole module, not just a class. Now, if you make a change in the UI here and you want to build the checkout, you need to build the whole thing again.
Yeah.
Because cross modules, you need to recompile the whole module. It's not per file anymore. Sure, this can be improved in the future with improvements in the compiler, but be aware. If you check actually your build times, you can see that you're making changes into small classes and you are affecting 10 other modules there don't even use that class. And that's a problem. That's why you want to minimize dependencies so you can build things on their own, deploy them on their own.
Yeah. And out about implicit dependencies, I even saw bigger teams that just disable that option. So if you need to depend on the other module, you have to do it the old classic way. Like you have to go in and link it and like make it explicit.
Make it harder.
Yeah, make it harder, exactly.
And you're also going to see it in a pull request as well, right? The dependency is being added to a module. You can see there. Because you also have these implicit dependencies that sometimes it works because you built a module before, but when your colleague clones the repository, you cannot build because there's a problem with the dependency that was not added explicitly, right?
Yeah.
Because Xcode was smart enough to find the dependency in the derived data. But if you don't have that already pre-compiled in the derived data, it's not going to work.
Yeah, dealing with modules is very complicated. That's why people built CocoaPods and Carthage, Swift Package Manager, just to hide this complexity away from us.
Yes. It makes it easy for us to deal with modules, but also make it easy for us to make a mess.
Yeah,
right?
Yeah, exactly.
Do you create a separate module as an Xc framework or an Xcode project in a workspace? Well, as much as possible, always start with the simplest. The simplest is to just create a workspace. And if that's not working for you, then maybe you think of a package, and then maybe you think of a Xc framework. It depends how you want to deploy it.
Those are not exclusive.
Yes.
So you can have an Xcode project that its output is an Xc framework or whatever kind of framework you want.
Just CocoaPods is pretty opinionated. You need to use a workspace like the way they created that for you. The Carthage, like it just builds for you and then you manually import it. But it's not supported anymore, is it? I think Carthage is gone since SPM was introduced. What is the implication of adding a third-party framework using package manager like CocoaPods or adding its binary to the project? If you add the binary, you don't need to compile it. So it can be faster. You need to be compiling it every time you clean the cache, right? The problem is that you need to have the binary in the right architectures, which can be very large if you have all the architectures available. So you could have a strategy of having a debug binary for debugging for development, and for release you actually do a full build and testing of the latest version. There are many strategies. It depends what you're trying to do. But you need to have all the architectures. Like maybe someone is on M1, someone is on Intel, and you also need a simulator and a device for releasing. So you need to have all those binaries in all those different architectures. And that can get really large. We've seen binaries like the Realm binary. How much was it? 2 gigabytes?
Yeah.
So it was something ridiculous. Like you cannot even push it to Git, you'll be rejected.
That should be a sign, right?
Yeah. And GitHub would say, no way. Thank you again. See you all tomorrow.
Bye, y'all.
Bye.